Hey everybody, hope you're all doing well. Before I jump into number three, I just wanted to point you towards some information regarding the AP test. Now, if you've been watching all my videos and reading everything that I post, you've probably already seen all this, but in case you somehow missed all of it, please check out Google Classroom for some information regarding the AP test, specifically when it's going to be now, what time. You're going to be taking it online, so you want to make sure you're logged in and ready to go well before 2 o'clock on May 12th. There's some information about the format. It's basically going to be two questions, a 25-minute question and a 15-minute question. Um, and there's a link here to just a little bit more information. So make sure you check all that out so you know what to expect from the AP test. And if you have any questions at all about it, you just let me know, okay? All right, so let's jump into number three. Let's see, what do we have here? Okay, the graph. Oh, first, I chose this question because through all four parts of this question, we're covering a lot of calc topics. So this kind of runs the gambit on a lot of material that was covered in this course. So this is definitely a good candidate for the style of question you're probably going to see on this new AP test. I don't know specifically what kind of questions they are going to ask you, but I can make an educated guess based on what I've seen in years past. So this is definitely the style of question I would expect to see. All right. So we have a graph G that is the derivative of f. So we could have just called it f prime. The function g is a piecewise linear function between -5 and 3. They're just making sure we understand these are all straight lines and there's no funny business going on. And then we have a parabola that is the rest of it. Okay, so if f of 1 equals 3, what the heck is f of -5? Well, if I can integrate g, because we could have just called it f prime. That would have made this make a little bit more sense. But if you integrate g, or f prime, which is what it really is, if you integrate that, you'd get back to f. So obviously that's what we want to do, right? I'm going to integrate this function to get back to two values of f, if that makes sense. I'm going to utilize the fundamental theorem of calculus. So this is what I'm doing. Let me just break down my actual work here. If you integrate g of x, which is f prime, from -5 to 1, then that would get you back to f. Integrating f prime gets you back to f. And then if I evaluate it from -5 to 1, then essentially I've got f of 1 minus f of -5. I hope you follow this. This is the fundamental theorem of calculus. Now, f of 1 was given to me. It's 3. F of -5, that's what I'm trying to calculate. And this whole integral on the left here, I can calculate that geometrically. If I pop back to here, from -5 over to 1, I can do all of that geometrically. I've got a square, and then I've got a long, tall, skinny triangle. Then I've got a completely flat bit that's just going to be 0, and then I've got another triangle right here. So I can just add up all those areas, which is what you see me doing here. Sorry. There we go. So we have -9 is this square. That square right there is 9 square units. It's negative because it's all below the x-axis, so that's that much. Then I've got a 1 by 3 triangle, so that area is 3/2, and again it's negative because it's below the x-axis. Now this is stupid. I'm saying plus 0. I'm just making it explicit that I'm adding this area, which is all 0, a 1 by 0 rectangle. Okay. Then we've got a 2 by 1 triangle, so that area is 1. So geometrically, I calculated the integral of g from -5 over to 1, and that's going to be -9.5. Then I just rearrange this, and I solve for f of -5, which will give me 12.5, or 25 over 2. This part of number 3 is worth 2 points. 1 point for explicitly stating that you are evaluating the integral of g of x. If you just kind of put all this work on your paper, starting with like this, knowing what you're doing, but you just start adding up the areas and then set it equal to 3 minus f of negative 5, you aren't wrong. You're just not really explicitly stating where all of your information is coming from. So you have to make sure if you have any answer, it has to be backed up by an integral. So this is your answer, and that's obviously worth 1 point, but you have to back it up with this integral expression or it's sort of meaningless. Okay? So that integral worth 1 point, this answer worth 1 point, whatever work you show to get from here to here is fine with me. It's probably going to look exactly like this, but whatever. So that's part A. Cool? Part B. Whoop, whoop, whoop. Part B. Evaluate the integral from 1 to 6. Okay, well, if I integrate g, I get back to f. And if I'm going from 1 to 6, then I could do the 1 to 3 geometrically. That's just 4, right? That's just going to be a 2 by 2 square. And then from 3 to 6, I'm going to have to actually integrate this. There's no way to do this much of it geometrically. I'm going to have to do it some actual calculus. So that is what we are doing here. This is a 3-point question. So 1 point is going to be for recognizing that you need to split up this integral. You're evaluating the integral of g from 1 to 6, but you're going to need to split that up into the integral from 1 to 3. And I put this off to the side because I didn't think to explicitly state this integral, even though I tell you to do that all the time. The integral from 1 to 3 is 4, so that's where this 4 came from, plus the integral from 3 to 6. Now I probably should have explicitly written it as the integral from 1 to 3 plus the integral from 3 to 6. Like I said in the last question, you shouldn't do anything. You can't just throw a number out there that isn't backed up by some integral. Okay, so I did just jump right to 4 because of how obvious it was that this area is 4, but I probably shouldn't have done that. So in hindsight, I went back and explained where that 4 came from. 4 is the integral from 1 to 3. So you get 1 point for recognizing that you should split up your actual integral into 2 sub-intervals, or integrals. One that you can do geometrically and another that we're going to have to do using calculus. So this one was 4, duh, that was easy. You're going to get another point for actually integrating this. So recognizing that this integral would go back to being 2/3 x minus 4 cubed. If you have 2/3 x minus 4 cubed anywhere in your work, give yourself a point. Now we're just going to evaluate that from 3 to 6. Plug in 6 and we get 16/3. Plug in 3 and we get negative 2/3. So that's going to be 18/3 or 6, blah, blah, blah. We get to 10. Bam, done. So 3 points. 1 for splitting up your big integral into 2 sub-integrals. Another point for successfully integrating this part of g of x and getting this expression. And your third point for getting an actual answer of 10. Okay. Part C. Alright, so from -5 to 6, on what open intervals is f increasing and concave up? And give a reason. Well, if you want to know where a function is increasing, you want to figure out where its derivative is positive. If the derivative is positive, the function's going up. If you want it to be concave up, you're looking at the second derivative. If the second derivative is positive, the function is concave up. So that's what we're looking for, a combination of f prime being positive and f double prime being positive. So, not that we have an actual function here to look at, we can just do all of this from the picture. F prime is g. So I want to figure out where f prime, aka g, is positive. Now, the set I'm going to use to support my answer at the end is going to be in the form of this number line that you've seen us use before. So this number line, as long as it is correctly marked f prime, will stand up in court. Anybody grading this will understand what you're doing and what you're saying with this number line. So I get these critical numbers from where f prime, or where g equals 0. And it equals 0, well, everywhere from -1 to 0 technically, but I'm not going to write down all those numbers. I'm just going to use -1, 0, and 4. So g is negative this whole time, and then it actually is 0 for a while. That's rare. And then it's positive, and then it's positive again. So that's what my number line looks like. F prime is negative this whole time, and then it's 0, and then it's positive, and then it goes right back to being positive. So we are increasing on 0 to 6. It doesn't really matter if you're including 0 and 6 or not. No one really cares. So open brackets, close brackets, it does not matter. Okay, so we're increasing on 0 to 6. Now let's figure out where it's concave up. That means we're looking for where f double prime, aka g prime, equals 0, so that we can see where g prime, aka f double prime, is changing from positive to negative. So g prime is the slope of g. So that means the slope of this is 0, the slope of this is positive, then it's 0, then it's positive, then it's 0, then it's negative, and then it's positive again. So f prime was g, so I just cared about this being negative and negative, and then 0, and then positive, 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 positive. Now we're looking at the slope, g prime. This is 0, positive, 0, positive, 0, negative, and then positive again. So that is what my number line is going to look like. So the slope was 0, then it was positive, then it was 0, then it was positive, then it was 0, then it was negative, and then it went back to being positive. So it's concave up here between -2 and 1, here between 0 and 1, and here from 4 to 6. So where do those two things overlap? Looks like from 0 to 1. From 0 to 1 is positive on both of those number lines. And 4 to 6 is also positive on both of those number lines. So that is enough evidence to prove that you are increasing and concave up on 0 to 1 and 4 to 6. Again, no one's going to care if you're using open brackets or closed braces. So 2 points for this question. 1 point for the actual answer, and 1 point for somehow justifying your answer. And we typically use these number lines. So I guess I should probably be pointing at the number lines here, but if you have somehow proven you are increasing on this interval and concave up on these intervals, probably using these number lines, or I don't know how else you might have done it. If you have a question about what you did, shoot it my way. This is how I always do it with number lines. So 2 points for this, 1 for the answer, and 1 for supporting your answer somehow. Okay, let's jump to D. Find the x-coordinate of every point of inflection of the graph of f and give a reason for your answer. We sort of did all the legwork for this in the last question. You have a point of inflection when f double prime changes from positive to negative, because that means you went from concave up to concave down. Or if it changes the other way, if you change from concave down to concave up, you have a point of inflection. So you're looking for where f double prime changes from positive to negative or negative to positive. Well, that's only going to happen right here. See, f double prime, aka g prime, is 0 and then positive. That's not a point of inflection because we didn't go from positive to negative or negative to positive. We went from 0 to positive. That's not going to make a point of inflection. And then this goes from positive to 0. That's not going to make a point of inflection. Then 0 to positive doesn't make a point of inflection. Positive to 0, again, not a point of inflection. 0 to negative, not a point of inflection. Negative to positive, there you go. That's a point of inflection because you went from concave down to concave up. Here you went from no concavity to concave up, to no concavity, to concave up, to no concavity, to concave down, to concave up. This is the only place that you actually change from concave down to up or up to down. So for that reason, this is a 2-point question. The only point of inflection is at x equals 4 because f double prime changes from negative to positive. So 1 point for the answer, x equals 4, and 1 point for justification. Okay, hope that makes sense.